Tangible interfaces are very popular and have many important benefits, but they are difficult to design since they mix electronics and shape. Researchers have explored making fully 3D printable tangible input devices that use embedded conductive filament, which makes tangibles easier to build. But these devices are static once they are created and can't be reconfigured to adapt to different interfaces or situations. Towards solving this problem, we introduce ResRecon, a technique for building resistance-based, reconfigurable, tangible input devices. ResRecon devices rely on resistance, which we control through both permanent geometry and effective geometry. We use printed permanent geometry to encode the identity of input components. Effective geometry is linked to user interaction. Here, as the user slides the slider, it connects through different parts of an embedded coil, thus modifying the path length between the user and the end of the circuit. We can sense these resistance signatures using a commercial touch input device. ResRecon devices use a hub module at their base to which users can attach multiple input components or pass-through components. Pass-through components enable changing the geometry of the input device without affecting the sensing. Components can also be stacked. We evaluate how to create workable coil geometry, how reliably our inputs can be distinguished by the MacBook touchpad, and how many layers of components we could stack using our prototype system and material. We also created 2 applications. In the first, we use a ResRecon device to control music. When components are added to more sides, more tracks and controls are added. In the second, users can control an on-screen character. Pass-through blocks are used to make the input device geometry better match the character geometry. ResRecon represents the first steps towards a future of fully printable, reconfigurable, tangible interfaces.